No.
All right.
Okay, you're on.
Okay.
Hey there, you stargazers. Here we go again. Some of the elders and the hardcore members of South Central California Coast Longtime Astrophysics Club, the Santa Barbara Astronomical Unit, proudly present our 223rd episode of the SBAU Astro Hour. I'm your proud host, Ronnie Herron, for this week of June 2nd through the 8th, 2025. We're going to cover these celestial topics this week. Morning star reached its greatest western elongation from the sun. It's 46 degrees. Our moon is reaching first quarter tonight near the hind end of Leo the lion. We're going to check out the moon's surface. Do you know there's a lion cub up there? Summer solstice about to begin. It's coming. Summer triangles rising in the east. I'm going to introduce you to a four-star asterism called Job's Coffin. Ooh. And what's a TNO? Well, it has something to do with Neptune. And we're going down into the quantum world this week, checking out hydrogen atoms. Do you know that neutrons decay? I didn't really know that. I like to say SBAU is Santa Barbara's fun club, gang, because astronomy is indeed the fun science, just like the universe itself. Astrophysics keeps expanding. Come join us in the fun up at the Santa Barbara Museum of Natural History. And we got just enough time to sign up and take part in our big June potluck this Friday night. We're all going to stop eating tonight or tomorrow, so we'll have an appetite by Friday. Find us at sbau.org. Let me introduce you to the gang, starting with the man in charge, the commander of this starship, is beloved President Jerry Wilson. Hello, Jer.
Good morning, and good
Jerry.
morning to you, Joyce.
Yep, and he, like many of the guys in the club, is a veteran of the old R&D world out there on Hollister Avenue. He's married to Pat Forgy, and our outreach guy is also one of those. Coordinator Chuck McPartland in front of the Ukraine flag. Wife is also Pat. She's our merchandise manager and a great treasurer. Who also signed in? Well, by signing in, we say Bruce Murdoch was on board. He's married to Bonnie and quite a guy, knows a lot. He's president of the Santa Barbara Theater Organ Society and is sort of a mentor to me on a lot of things. Tim Crawford signed in, resident lens and telescope expert. What is it behind you? Is
That's
that
a that's a shot
okay?
of the sun that I didn't do, but it was done with a scope that I have possession of now. So if I ever
Oh,
learn how to do it, it'll come out like that, maybe.
Wow.
well, I don't think I've ever had your career. What did you retire from,
I
Tim?
was I was a dental technician, the tooth fairy.
You're kidding me.
No.
Well, I'm going to stay away from you then. My
Oh
God.
yeah.
And how's Karen, your wife?
She's doing great. We worked her to death yesterday rebuilding a fence, and we're both suffering for
Hmm.
Yeah, and Bruce is caring for his wife, Bonnie.
All
Godspeed
right.
on her health. And doggone if Mr. Whittemore, Tom Whittemore,
Morning.
former Westmont science
Dr.
instructor,
Whittemore.
Oh,
Dr. Whittemore is married to Maureen. He used to have something to do with taking my blood donations every 2 months for the thinners. Let's go to the silly stuff because we've been doing this now for 4.5 years almost. And I'm not sure how much science is in these, but we do have some thought provokers and some great fun stuff that starts out the hour every week. And you're going to have to enlarge that and maybe, is it washed out? Maybe not. Two guys. Oh, okay. Can you see the cows around
it.
this space shuttle about to be launched? One
yeah.
of the scientists said, part of me thinks we should wait for them to move the other parts. The other part says, I love the smell of steak here. A
Yeah.
quick barbecue like this. Never mind.
Can you see the employee
Yeah.
of the month over here?
Yeah.
Okay, AI's got to work out this washing
And
out thing, but
Kick
I think
me.
we've got it.
kick
Well, it's
me.
eye juice. Never seen eye juice before. That's scientifically connected. Let's go to the next one. How my brain works. It's either on with utterly obsessed or turn it off uninterested. Isn't that true? You're either totally into it or forget it. Now, this poor dog, uh-oh, let's trust me, there's a dog lying on the bed.
Oh, you can't see it well?
It's
I
showing
can-
fine here.
Take
could
too
see
much time to change over. I can read it at least. Suffice to say, oh, you're going to change it over? I was reading up close there, Jer. I don't suppose you could stay on that
I'll give
bright
it a
and
try.
clear, unwashed. Well, it's a great comment. A caption at the below is hitting home. Here it is. Buster the dog would sometimes spend entire afternoons going over and over the idea of an ever-expanding universe with its pulsating Cepheid variables in the large Magellanic Cloud and what his role was within it all.
Well, that's a good dog.
That's
That's
a
a
good
good
dog.
Okay, this is the band not counting sheep, but counting sheep formula, sheep equation.
Sheep calculus.
Okay, this is how mathematicians go to sleep,
Yeah.
or
Or don't.
physics instructors. It's a great one. Okay, this one is a good one for you cat lovers. The cat checks in at a cat hotel, and the guy behind the counter said, "You know, we got a cardboard box for $30, a laundry basket you can rent for 50, or the top of the fridge, our penthouse, $125." They check in, but do they check out? Here's an interesting one. This hit home with me because I just took delivery of a cube. The license number, the plate number on this cube is C6H1206, chemical equation for glucose. That makes it a giant sugar cube. You guys want to hear the license number on my cube? I haven't figured it out yet. It's E.MC2. I don't know what that means. Okay, here we go. We're looking through the back end of the old-fashioned type of telescopes, and the guy goes, "Whew, this is two views of an asteroid. That was close. If that killer asteroid hit us, it would have been a disaster." Meanwhile, the rock is thinking as it head back into straight space, "Whew, that was close. Thank goodness I missed. That place is already a disaster. Doesn't need me." Perfect. This one I
like that
didn't see. You want to read it, Mr. President?
Oh, yeah.
I
That's
shall
right.
grant you 3 wishes. I wish for a world without lawyers. Done. You have no more wishes. But you said 3. Sue me.
Yeah, that's great.
A good one.
I did see that a week ago. All right, shall we read this? A couple of days ago, when my math teacher asked, "Any questions?" You're going to have to go about this one. I asked, "What's the meaning of life?" She simply replied, "The meaning of life is math." Today, we realize that in the alphabet, M is the 13th letter, A is the first letter, T is the 20th, and H is the 8th letter. 13 plus 1 plus 20 plus 8 equals 42.
42.
And you want to explain that? Because I didn't get it.
42 is the answer to life, the universe, and
Yeah.
all that. According to, who's the author of that book?
Douglas Adams.
Yeah, Hitchhiker's Guide to the Galaxy.
Mhm.
42? What does that stand for? 42 what?
That's a
That's the
different
answer
question.
He just said
42
that.
units.
Okay. I missed that one, but that's
No, you
interesting.
got it, but you don't know you got it.
I've seen the movie. Zoe, what's her name anyway? Okay, what
Deschanel.
do we got here?
Yeah.
This is a pair of pliers. Bruce, you want to explain more about this? What the heck is this then? There's 2 of them.
That's 2 pair of pliers.
Mhm.
Actually, it's
The-
2 pairs
each
of
half the
pliers.
plier- each half of the plier is a plier. Is a lever that you use to spudging things and whatnot. Well, you got 2 of them attached to the fulcrum. So it's a pair of pliers.
Okay, you never see a plier by itself. It's always with its other buddy.
No, you
Okay,
do. They're called
Broken.
pry bars.
Anybody
Yeah.
else? Anybody else on the screen want to read this one and comment? Whittemore?
With this one,
Yeah, read it
Yeah.
to us.
why do we say sleep like a baby? Babies wake up every 2 hours crying. I want to sleep like my cat. 14 hours, no responsibilities, 0 regrets.
That how life is at your house, Chuck?
Yeah,
Captain
yeah.
Rich?
Except there's 2 cats sleeping.
Well, they certainly like to hog the limelight by walking in front of you every so often.
The garbage trucks came early today, so they're both hiding under the bed.
To the night sky, or is this the early morning sky? We go.
Early morning.
Yeah,
Mhm.
Okay.
this is
If you could see it.
Morning
Showing-
star. Good morning, star. There's six
Venus.
stars on my screen. They're lined up on the right side.
right there. Venus has now come around the sun, or gone around the sun, I guess, because it's moving away from us. It passed on the near side of the sun without occulting it. And now it's about maximum, what's that? Displacement? No, offset, whatever. And it's
Elongation.
elongation, thank you.
Yeah.
Yeah. And it's very bright, magnitude minus 4.4, I think. But this is what it looks like at 5 a.m. in the morning sky. The sky is starting to get light.
Mhm.
The planetarium program shows it accurately. The sun's about to come up. Saturn and Neptune are over here.
Mhm.
And there's a star over here named after a hotel chain.
Slightly misspelled.
Yeah.
The
slightly.
Howard Johnson,
Yeah,
the Hiltons or the Howard Johnsons?
the Sheraton.
Sheraton. Can you answer me a question about Venus? Is it the same in Australia?
Yeah.
I mean, yeah, it's distance
They
from
have
the
it.
sun.
It's their night and morning closest.
But Venus will be upside down.
Yeah.
So if it transited under the sun for us, it was over the sun for them. Is that what you're saying?
No.
Yeah.
No.
It wasn't a great apparition, was it, Chuck?
No, not really.
No, no. We see it every morning when it's not cloudy. But, yeah.
When is that?
I'm up at 5:40, you know.
But
can still see it.
Australia never sees the Big Dipper, obviously, do they?
Depends
That's-
where you are. Northern Australia, you can see it.
Yeah.
Oh, no kidding, really.
So it reached maximum western elongation, I believe over the weekend. And tonight it reaches what's called dichotomy, which is what we would call the first quarter for the moon,
Mhm.
where it's exactly half lit and half dark. And this is a photograph of dichotomy from 2017.
Dichotomy.
It means two.
Mhm.
That's
Guy.
Venus's crescent.
Now if you look at this, if you look at it with one of our amateur telescopes,
Mhm.
it's easily capable of showing this disk. It's really quite large. Yeah, in terms of planetary images, it's about 45 seconds of an arc this way. And Jupiter at its largest gets to be about 50 or 52 seconds of an arc. So you can easily magnify to see this. But if you look at it in the dark of the night, like the map we just showed, you won't easily see the half or the disk because it'll be so bright in contrast to the black background that the glare will obscure your ability to see the phase. The easiest way to look at Venus is during the day.
Mhm.
Always avoid the sun. Death from the sun would be instant for your eye. But keeping away from the sun, you can actually see the phase of Venus very well during the day. And with these modern computer-run telescopes, finding Venus in the day is no problem.
Where did you get this picture?
I got it off the internet.
Oh, okay.
And I believe I got this from the website for Astronomy Magazine.
So
I go to either Sky or Telescope or Astronomy or a bunch of other places that I can trust. A lot of places with really good images that you can't trust. But the Astronomy Magazine does a short week of coming events, and I use that first.
Why is this so fuzzy?
You mean why is it not sharp? It's a photograph and there's seeing effect. So I think that's a good image.
Plus,
Yeah.
there's
Oh, yeah.
atmosphere, you know, on Venus too.
Yes. Mhm.
Now, tonight we're going to have, as far as the moon is quite prominent. We have first quarter tonight, and we're going to look at 3 very prominent craters. But if I made this for tonight, where it was cut this way, these craters wouldn't show. So I moved it over a day. So this is what the moon will look like tomorrow night. This is Ptolemaeus and Alphonsus and Arzachel.
Orzakel?
Arzakel, yeah, right here. These very prominent, very nice features to look at, especially Ptolemaeus.
That's a Tim favorite.
Oh,
Yeah.
yeah.
But I'll bet Tim has never been there. So but it has a lava-filled floor. Well, let's just go to it. Now this is the 3 together.
Mhm.
And it has a lava-filled floor. And when it's close to the terminator like
What's
this,
going on
you
here?
get little waves and bumps. So it's really got a lot of structure, a lot of features in it. This one has lava filled. This one is, parts of it have been liquid, but this is a rebound from about the time it froze. So it has a central peak, and this one has a central peak in it. It's a smaller crater. The bigger one does not have a central crater. It stayed liquid a lot longer.
And Jerry, on this, I think it's Alphonsus that the rim of the crater overlaps Ptolemaeus. You know,
Yeah, right there.
yeah, and
This is-
showing which one, which one was earlier, which one came later.
Yeah, good observation.
Well, gentlemen, if we were ever to witness one of these being created, a giant asteroid hitting, would that liquid you just described in the middle be bright red and yellow? And
I'm gonna log in again. I keep losing this.
It would start out as a liquid, and it would be pumping out infrared radiation like a champ. And as it cooled down, the temperature would drop, and the amount of infrared coming out would decrease. So I don't know if it would show a lot of visible colors. It would be very bright if you happen to be looking at it when something like this hit. I don't think we've seen littler things hit where there's a bright flash, a light, and then satellites around the moon, which we have many. We'll take a picture of that region, and you can see a brand new crater. These are all small scale stuff. Nothing of the scale of these 3 craters so far. This is a close-up under higher light of Ptolemaeus, and you can see a lot of small craters in here. It's been hit a
Yeah.
lot.
Boy, that's something else there.
This was a picture taken by let's see if they did Apollo 16,
Oh, wow.
as they went zooming over.
They didn't have to deal with seeing.
No, as long as they had their turn at the porthole.
but a large version of one of these would be called a C or a Mari.
Yes, a very big one, yes.
Okay, and yet they're dusty. They're all dust somehow.
That's because of all these small craters in there, and other hits. It just pounds the surface and breaks it up over billions of years, and that's where all the dust comes from.
Boy, that's really.
So it's not flat and hard.
Well, it is under the dust.
Yeah.
Oh, and it's very abrasive stuff, apparently, to equipment, for example.
Yeah, it's basically microscopic shards with sharp edges. There's no wind erosion or rain erosion to rub things against each other and break the points off. It's not like beach sand. If you go to our beaches and get some sand and look at it under the microscope, the sand grains are all rounded. That's why you can't clean the salt out of it and use it as an aggregate in concrete, because it doesn't grip the concrete like it should. You have to get sand that has been still has its sharp points on it. That's why they have rock crushers. They get gravel and they crush it up to get sand to use for concrete.
So Do you suppose when Neil and Buzz came back to Earth, they had to clean that stuff off their spacesuits?
Absolutely.
Well, they got all kinds of stuff from the moon without even collecting it on purpose.
Yeah, also those little insects.
Yeah.
Oh, yeah.
You heard about those, right, Ron?
Moon bugs. Yeah, right.
Oh, lunatics.
I saw that one coming. Or should have seen it.
I have a great I think it was Apollo 11 when they came back. It's one of the ones where they were picked up by an aircraft carrier and they were dropped off in Hawaii. And Hawaii required them to fill out a customs declaration. And they said,
Oh,
have you been
bring it.
exposed to any diseases or pathogens? And they put something like remains to be seen.
Well, I wonder if that's going to be a problem for future space flight. Are they designing suits that can repel that stuff, you suppose?
Well, apparently it sticks electrostatically to the suits.
Ooh.
Oh,
It's
So
got a
it's-
lot of bits of nickel iron in it.
Yeah,
Oh boy.
that static cling.
Yeah.
well,
But it is abrasive, and apparently someone made the remark after the Apollo program that going in and out, their suits shed enough moon dust that when they closed the hatches, it was abrading the seals on the hatches.
Oh boy.
And so if they had stayed there for another, like a week or more, the hatches would have lost their ability to seal the atmosphere in. Now, I don't know if that's true or not. I just heard that.
I've seen
Sounds
that
right.
too.
You what?
I've seen that also.
Okay. So they're having to design new suits and new seals that are resistant for this, for people that are going to spend some time up there.
Or a Hoover vacuum.
I don't think the vacuum is going to do it.
Combined with a magnet.
Yeah.
amazing.
Okay, this is tonight
Mhm.
at 10:30 in the evening. I have my planetarium software set to always show a black sky, and I frequently forget to change from AM to PM. So I get confused about that, but I get it straight. I double and triple check everything before I put these up here.
So that's the moon on the left.
That's where the moon is in Leo.
Mhm.
And this is showing the constellation of Leo Minor, little Leo, the cub.
Hmm.
Yeah, notice we've lost Jupiter by this time.
Yeah.
Yeah.
I didn't realize Ursa Major was so close there.
Yeah,
Well,
you
it depends
poke a hole in the bottom of the Big Dipper and the water runs out onto the Lion.
Right.
Huh.
Yeah.
So this is, there's a lot of extra crap up here
Well,
with the
that's kind of technical, Jerry.
Lot
sorry
of
for
stick
using
figures.
technical words.
Also, you can see the 3 leaps of the gazelle.
Yeah.
That neat?
I like the stick
Where,
figures in the
here?
sky.
No,
Yeah,
no, no. The Talitha down there, there's Talitha Borealis and Australis or whatever.
Mhm.
So you're looking at the feet of the bear, the toes.
Yeah, there,
So
and
that's
there.
there, and there for the
Yeah.
right along in a line.
Right. They're called the 3 leaps of the gazelle.
Okay.
Actually, it's 2 leaps, right?
Two leaps of the gazelle. Yeah.
No, they call it 3 leaps, but
Yeah, they do say 3, Chuck.
yeah. But I'm just thinking it only takes 2 to make the 3 impressions.
Yeah.
I've never heard that.
I don't know what they're talking about either, folks.
Yeah, I've never heard that.
It's
Yeah.
the pairs
yeah.
of stars that form the feet there.
Yeah.
So there's so those are like footprints of a gazelle, jumping. They say
Well,
it's an
Where did
Arabic story.
where did the 3 come from?
Well, there, and then the hind leg there, Alula Borealis.
Oh, this one.
Right
Yeah.
there.
Oh,
Okay.
I
Yeah.
got you.
These are, Jerry, these are the kind of things you'd find in the Field Book of the Stars, which I grew up with.
Okay.
Those kind of things.
Huh. I'd never heard that, Tom.
Mm-mm.
Yeah, yeah.
So anyway, back to Leo Minor. Leo Minor is a small constellation. It has a very unusual thing that I've never understood, but I've always wanted to try and pronounce. Hannes Vorwerp. I don't speak Dutch. Do you, anyone here speak Dutch?
I
No,
can
guess.
try to
Okay.
knock it out.
I think it's Verwerp, but who
Verwerp?
knows?
I'm probably giving it a German pronunciation.
Mhm.
And it was discovered by a school teacher, I think,
Yeah.
named Hanny. And it's this green stuff down here.
I see.
So this is a galaxy
Yeah.
back here. And this was thought to be, if I remember correctly, it was thought to be a defect in the image.
Huh.
It's first discovered. And she persisted, no, it's real.
What fluoresces in the green?
What's
It's a
that?
nebula.
Why is it
I
green?
mean, that would be copper.
Well,
Oxygen.
It's
No,
very
no.
likely oxygen.
Yeah.
Yeah,
Oxygen
this
three.
is everything here is false color. It's just
Ah.
alignment.
Hanny's Vorwerp.
She was working on a Galaxy Zoo, which is a citizen science thing.
Yeah.
I see.
Space Oddity, is that a play on words from the movie or just
This is her name.
Uh-huh.
And then this,
Connie.
Hanny?
yeah. And
Yeah,
this is
okay.
what it is. And in Dutch, it means Haney's object.
Object.
So this is
Okay.
object in Dutch.
Okay.
So this galaxy, which is what you see in the background, this galaxy, this is the hypothesis of how this formed. The galaxy went by here, and there's a black hole in here. And so the gravitational tug was very strong. And so this galaxy goes by, and it left a tidal tail from this interaction between the two galaxies. And then the black hole at the center here turns on because it's now consuming a lot of this gas, which has been shaken loose by a close pass, as a quasar, and emits a powerful cone of light, which ionizes a portion of the tidal tail, creating Hanny's Vorwerp. It should be, from my German, it should be an F and a V. So
That's what I'm thinking. Vorwerp.
Vorwerp.
Yeah.
But Dutch and German are different languages, but they're close.
Mhm.
So gas streaming out from the galaxy's center impacts the tidal tail and triggers star formation. And that's what you get in this portion of the loop here. So it's quite a bit of analysis and guesswork. There's the star formation down in this region.
Wow.
And this is the ionized gas and dust in the tidal tail.
So we would see that more as a bluish green in our scopes with real color.
We don't have real color.
Yeah.
Color is a bright light effect in the human eye, and you can, whatever filter you look through it at, some would, of course, make it look brighter and dimmer, but I don't know which filters they used here, so I can't comment on that.
Yeah.
Oh,
Hey, Jerry, I just looked up the pronunciation.
Wait, one at a time. Bruce, go ahead.
I said, you said this was false color.
Yes,
Yeah.
yes.
So if we look at it through our telescopes, we see what the color as perceived by our eye would be, which
No,
isn't.
you can't see color in these faint objects. The human eye does not respond to faint color. So
I know.
there's no true color.
Been there, done that.
Yeah. Okay, Tim.
Yeah, I just looked up the pronunciation, and it sounds like H is pronounced like an H. Hanny's Vor, and then it is a V. Hanny's Vorport.
Okay.
Vorwerp. And did I miss what you call the bottom part, the green? Is that a nebula? Did I miss?
Yes, it's gas, which is a nebula.
Okay.
Nebula is a generic term, Ron.
Yeah.
Okay. Well, I'm not clear I generic.
Okay. The tidal tail was created by this near pass, and then the quasar sent out a cone of
Ionizing radiation.
yeah, and thanks. I was trying to get electromagnetic radiation out of my brain, but yes. So ionizing radiation, and it ionized a lot of this stuff to cause emission, and that and the gas streaming out here from the quasar hits this and causes emission, and it shakes things up and causes star formation.
So can I get this clarified? The Green Nebula is in our galaxy, that distant galaxy.
Oh,
No,
gosh, no.
Oh, it's not? It's
No.
not in our,
Oh, no.
we're looking at a nebula in another galaxy?
Yep.
outside of another galaxy.
Yeah, in
Matter of fact,
space.
galaxies used to be called nebulas.
Yeah.
Really? I thought nebulas were just inside our galaxy. I'm sorry, I've never heard of one in another
No.
galaxy.
It's
Yeah,
a
you
generic
sound a little
term.
nebulous.
Yeah.
Well, that galaxy is two arms, right? Two spread out wide, just two main arms.
There's two, looks like there's one arm there and another one there, which goes
Yeah.
around and is part of this tidal tail.
Well, I'll be damned. You can have a nebula. You can have a nebula outside of a galaxy working on its own.
Yep.
Yes.
Maybe it'll start enough stars that it'll just become its own galaxy.
Yeah.
Well, look at M51.
Wow.
You got a big star sucking stuff off a little star.
Maybe that's how Triangulum and the Magellanics were created. They started
Well,
out as
M51 is a big nebula sucking stuff off of a little nebula.
Yeah.
Yeah.
And most of the stuff you see there is stars that have been torn out of either galaxy.
Annie's Warwarp.
Okay, let's move on.
Yeah, I got it wrong again. I just checked, Ronnie. I was wrong. I don't know how to pronounce it.
In that case, you got it right.
Yes. It wasn't. It's just really.
Now,
I think
V-
you should stick with HSV.
Yeah,
HSV.
yeah.
Yeah, that's the technical abbreviation for it. Capital H, little s, capital V.
Yeah, well, the V's and W's are pretty much interchangeable over there in Eastern Europe.
That's the way it looks to an American. It's not the way it is.
Yeah.
What's one word that's always spelled wrong?
The worst, the most annoying switch I've seen is in Spanish for a V and a B. For example, in Americans would say Havana, Cuba, but it's actually Habana, Cuba.
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 Like a Q, huh?
Cuva, Cuba. Cuba is Cuva. B is V. B is pronounced V, and V is pronounced B.
That's like people around here, especially old timers around Santa Barbara, have a tendency called refugio.
Yeah,
But it's not an F sound, it's an H sound. It's refugio. It means refuge.
right. I noticed that when I moved here.
Yeah.
And also the letter X sometimes substitutes Tejas instead of Texas, Mexico instead of Mexico.
Or Chicxulub, where it's pronounced kind of like a CH.
I don't think they have the X in the Spanish language. I think they just have an H or a J, excuse me, a J rather. Or maybe I'm wrong. Never mind.
They have the X.
What about
They do?
Oaxaca?
Yeah. Oaxaca.
Oh man, that's amazing.
Chicxulub, it's the SH sound, in that X. But I think that's like a Mayan pronunciation.
That's what I'm thinking. All those X's came with the Mayans. Montezuma.
Next time
Montezuma.
Getting back to outer space.
Here we go. Yeah.
At 11 o'clock at night tonight, the Milky Way is spread out in front of us, and it's got Cygnus prominent in that sky, and Cygnus has a star cloud in it called the Cygnus star cloud.
The
And
swan.
when it is imaged with a deep photograph, this is the Cygnus region. This is Cygnus star cloud. This is Deneb. This is the Veil Nebula and the Witch's Broom here with 51 Cygni. What's that?
Yeah, you're right. I wouldn't have noticed that.
And it's just a massive star cloud. And all of this black stuff in here are not missing stars. This is nebula that's blocking our view of the star cloud.
Right.
You can
Often
see
called
the
the Great Rift.
Yeah, it's called the Great Rift, which implies that it's a hole, but it's not.
Yeah. And my brother called it the coal sack when I was a little kid.
There is a one of these things somewhere in the sky is called the coal sack.
I think
That's near the Southern Cross.
yeah,
Yeah.
it's in the southern sky. Yeah.
Yeah, and
It's just what my brother Paul called it.
I think it's called the Northern Cold Sack. So
okay.
Yeah.
Huh. Wow. Learning stuff
Back around
today.
1900, E. Barnard made a survey of all. He took pictures like this of all the star clouds and all the dark regions, and he made a catalog of all these dark regions, and they're called Barnard's nebula, and they assign a B number.
Mhm. Yeah. The famous one's B33,
Yeah.
which is that's right. Thank you.
So Cygnus, the swan, is pretty much superimposed over the band of the Milky Way in the middle.
Yes.
Yep.
Yep.
How many
Yeah,
of
this-
the
And you
The
how many-
stars,
I
Go
think
ahead.
Cygnus the Swan Rana is flying down the Milky Way.
Yeah,
You know,
this
that's
is
how
the-
I learned as a kid.
this is the
Oh,
tail,
that's it.
there's the body, there's the head with the long neck, wing, and these stars are very close to us. They're in front of the star cloud.
Yep.
So is this one.
Hmm.
Yeah, Barnard was at Lick, above San Jose.
Now, this is a listing of the sites around the star cloud, the easy sites for us amateur astronomers.
Mhm.
So we have BE 86. I don't know what these are not Barnard, is that what you
Oh
just?
no, not at all. Chuck, do you know BEs?
No, I don't.
Yeah, I don't know
Yes,
those.
okay. So the M's here are Messier objects, M29, and the circle denotes a
A
globular
Chuck
cluster.
favorite.
And this is Saturn is a star.
Mhm.
This is Eta Cygni or Nu Cygni?
I think that's Ada.
Eta, yeah.
Yeah, which is related to Eta Cygni.
Mhm. And this is Alberio. This is Messier 1. No, that's not a Messier object because it's not like that. This
That's
is
Minkowski.
Minkowski. Yeah.
Okay.
This is Messier 56.
Yeah. A
This-
nice globular, a toughie, but a nice one.
These are New General Catalog NGC. These are the ones that were done by the Herschels, started by the Herschels. It's been added to in modern times. It's probably the most common. If you can see it in the sky with our small scopes, it's most likely an NGC thing or an M for Messier. So
Mhm.
this is what's available in front of this star cloud. Some nebulas up here.
Yep. So it's a favorite, when I would take the Westmont refractor up to Seder, I'd always show them, colander objects. There's a colander up there, 421, and I'm just into open clusters. I
Yeah.
like even if they're not, really impressive, they're pretty cool.
Colander? What is that?
Per Colander he gives a cataloger. He was looking at open clusters all through the sky.
Oh,
And so
okay.
so the CR comes from Colander.
Oh,
So I think it was a Swede.
Oh,
Yeah.
what?
Yep. Okay.
There's several dozen different calendars focused on different types of objects.
Yeah.
And some of them
Mhm.
going very deep, things that you will never see with your amateur telescopes.
Yeah.
wow.
Yeah. The
Okay.
famous, I was going to say, Jerry, the famous coat hanger is a colander.
Yeah.
Brocky's cluster is a famous one. That's a colander.
Okay, now we're looking at Pallas, 14 Pallas, which is an asteroid.
Hmm.
The red thing down here is
Pallas isn't 14. Pallas is 2. So 14 is just
Oh.
your slide number.
Yes, you're right. Thank you.
Why we have you on board, Chuck?
Yeah.
To be a
You're the-
nitpicker.
Do the
Right.
fact checking. Yeah.
Now we want to get it right. So this
Yeah,
red
this is the
dot down
palace
here
of fine art.
is Pallas. It's in Delphinus,
Delphitus.
and let's see.
Yeah, Job's coffin.
This fits in kind of with the Chumash story of the Rainbow Bridge across from the islands. That's the Milky Way. And the story was the Chumash were told if you want to leave the island because it was getting crowded, you can go to the mainland and you follow this Rainbow Bridge, but don't look down. And some of them looked down and they got dizzy and they fell into the ocean. And Tutash didn't want them to die, so she turned them into dolphins.
That's neat. Yeah. And in Africa, that's the backbone of the sky, right, Chuck?
Yeah.
You
And in
mean the Milky
Australia,
Way?
it's where an eagle stole a burning log from a campfire and flew across the sky and left a bunch of cinders,
And then above them was the Icarus guy who flew too close to the sun.
To backtrack just for a bit, the BE stands for Berkeley.
Oh, okay.
Oh, Birkeland. That's right. Thanks, Tim.
Okay.
Those are toughies.
Yeah.
How much of this am I supposed to retain, gentlemen?
None.
All of it. Quiz after the program.
Okay, got it.
Okay, there's a bad astronomy joke in this image.
All right.
Uh-oh.
So you see there in Delphinus, you got Suallicin and Rotanev.
Yeah.
Yeah.
So the story was that Piazzi had an assistant named Niccolio Cacciatore, and it means Nicholas the Hunter. And he was teaching some other students about astronomy, and they were studying double stars. And there's a lot of double stars up in there. And the students liked the guy so much that they decided they were going to name these two stars after him because they realized they didn't have any common names. So they said, well, Niccolio Cacciatore is way too Italian. It means Nicholas the Hunter. So they took those in Latin, which is Nicolaus Venator.
Right.
And then they spelled them backwards.
Oh.
Okay.
Oh, God.
But it was Piazzi who named it that in honor of his graduate student. But the story he put out was that it was his students.
Okay. So anyway, at 2 a.m., you can find Pallas. You won't see anything but a dot. It can't be resolved into a disk. But it is one of a large number of dwarf planets and asteroids.
That would be moving against the background of the stars.
Yes, it will. That's how you can tell what it is. You look at it one night, make a drawing or a sketch, or you have a good memory, or take a picture. And then a few nights later, you look, and if it's moved, it was an asteroid. These are the largest known trans-Neptunian objects, TNOs. This is Pluto, of course, with its 5 moons, Hydra, Nix, Styx, Kerberos, and Charon. Then there is, what is this, Eris. And Dysnomia. This is Haumea. This is Maki. Go ahead.
Those first 3 have moons. Those little ones are moons around them.
Around, if they're close to one of the big ones, they're moons.
Almost all of these have moons if you look at it.
So Ron, trivia question for Ron.
Okay, shoot.
Why is Haumea shaped like an egg or like an oval? Chuck, don't tell him.
Who?
It rotates real fast. In its creation, it basically egged out. It really did. I saw Maureen and I watched a program last week about this particular trans-Neptunian.
Oh, I think I showed a picture of this to Jerry several months ago.
Maybe.
It's football shaped.
Yeah.
Because of its spin.
Yeah.
Early on, when it was fluid. So it just spun into that shape.
Well, the Earth qualifies us to be lighter if we're on the equator than at the poles, right?
Yeah.
I'm thinking of moving to Ecuador just so I can lose weight.
There's a scientific.
Move to the moon.
Yeah.
There's a science fiction short story I read when I was a kid about a planet that was spinning so fast that it had this shape. It was an oblate, or what is it? Oblate spheroid.
Yeah, right.
And so you could hike to the poles where, get away from the equator, or no, you could live at the poles. But if you hiked to the equator, you were above the atmosphere. So you were in the vacuum of space.
Wow.
Well, some of those spinning neutron stars are going hundreds of times a second, aren't they?
Yeah.
Yes, some of them
Why
are.
aren't they just discs?
No,
No.
they're really tough material though.
Oh,
The-
yeah. You're
the-
talking pulsars.
The stuff that would have been in the disc has been thrown off.
Mhm.
Oh, is that right?
So,
Hey, Jerry, I'm confused. Why would you weigh less at the equator? Is it centripetal force that causes?
You're being thrown out from the earth
Yeah.
more than the poles.
you imagine wherever you're standing, you imagine a sphere under you inside the object.
But it's spinning, Tim. You're being spun on the outside of the merry-go-round.
Yeah.
Up at the
So the
pole, you're
reason
sitting on the-
reason it's bulging is because the centripetal force is a counterbalance to gravity, and it's throwing it out that way.
And that's why you'd feel like you weighed less, Tim.
Yeah.
Plus, you'd be farther away from the center.
Yeah.
Okay,
Well-
okay. Huh, interesting.
Okay, now let's have someone take the risk and try and pronounce all these names that I didn't pronounce.
No way. I got
Maki-
MK2.
Okay,
Yeah.
what's this one?
Going,
Maki,
gong,
Maki, I
gong.
think.
I think going, gong, gong.
Yeah. Jean Gliu,
Okay.
Mhm.
Kwawar,
Jean
Kwawar, and Waywat.
Glue.
That's an easy one.
That's it, huh?
Yeah.
Quora and
Okay.
Wig, now that's got to be a cartoon.
So
Quora.
it's I think South American Indian names for
Yeah.
various goddesses.
Remember to be taken serious, take all this seriously, because you're insulting other people's gods.
Yeah.
Oh,
Orcus.
But they're, gentlemen, they're all dwarf planets.
No.
And they're out and they're in the Kuiper belt, or
They're not all officially dwarf planets. They're
No.
trans-Neptunian objects, though.
I thought a dwarf planet was always spherical shaped,
It is.
not potato.
Hydrostatic equilibrium, Ron, not necessarily a sphere, just hydrostatic equilibrium. So if it spins fast, it can be football shaped.
Now, these are trans-Neptunian objects, but there are objects inside Neptune's orbits that are represented here for size comparison. The Earth's moon, and of course the Earth, which are not dwarf planets. But the dwarf planet Ceres, which is in the asteroid belt, would be this size here. So a lot of this stuff out here is much bigger than Ceres, which is about 600 miles in diameter.
Isn't there one out there with a Hawaiian name out
That's
past?
Haumea.
Oh, where is it? Oh, there it is.
That's your friend, yeah.
Oh, I
could somebody
I
help me
thought
with this?
Maki
What
Maki
is-
was Hawaiian too.
Yeah, it sounds
Maki
Hawaiian
Maki,
too.
no. Okay, so the story on these, when Mike Brown had that whole episode with wanting to call Iris Xena, the warrior princess, okay, and the IAU said, no, we're going to give it an official name just for fun. When he discovered Maki Maki, he said, let's call it, he discovered it on Easter Sunday, so he said, let's call it the Easter Bunny. And they said, no way. But they called it Maki Maki, which is the creation god of the Rapa Nui culture, which lives on Easter Island.
Okay.
Then with Haumea, he found that, and he said, I think he wanted to call it Santa Claus or, something like that, because he discovered it in the wintertime. And it has these two icy moons. It formed from a collision. There's icy debris in its orbit. So they said, let's call it Haumea, which is a Hawaiian goddess of childbirth. And her story is she breaks off pieces of herself and they grow up to become children. And so that's the Namaka and Hiaka. Those were two daughters of Haumea.
Now, this elliptical line he just referred to, these are the fragments orbiting as a ring
Yeah.
on Haumea.
Oh, it's a
Now,
ring.
we have just discovered in the last few days, or decided that it is another trans-Neptunian object and dwarf planet.
So what exactly I don't understand the difference between a dwarf planet and the trans-Neptunian.
Okay. Trans-Neptunian object is like a generic term, like nebula. Okay. It means it's beyond Neptune.
Okay.
Okay. Dwarf planet has this ridiculous definition and has to be in hydrostatic equilibrium, blah, blah, blah. And a bunch of these would qualify, but they have not yet been officially declared dwarf planets.
Okay.
But nature does not respect these different bins
Yeah.
and names.
We're just
Now,
trying to stick these things in bins, but the bins are fuzzy.
Right.
Okay.
So
Okay.
this is the orbit. There's our solar system. There's our sun. This is the orbit of Pluto in red. And this
Oh.
orbit here is Sedna.
Wow.
And this orbit is 2017 OF201, the newly discovered thing. It has no name yet. But this one, it's not very big. It's not a second Earth or Planet 9, but its orbit takes away from the fact that all the other orbits of the other dwarf planets all line up on this side. So this one goes out here, so it's in counter indicator for there being another Planet 9 out there.
But that isn't Planet 9.
It's too
No.
small to be Planet 9.
And there's a typo in that caption for the image where it says it's the second largest known object in such a distant orbit following Pluto, but it's smaller than Sedna. So I think they meant Sedna because Pluto's
Okay.
not in one of those really distant orbits.
But do those two orbits go out past the Kuiper Belt and into,
No.
or even past?
No, the Kuiper Belt, the Oort cloud goes way out there. So does the Kuiper Belt. This is not out of the Kuiper Belt.
No.
Oort cloud is about a light year out, isn't it?
I got 2 light years, I think, depending on
Yeah.
your definition.
Yeah, it's
That's
halfway
halfway
to
to
the
Alpha.
star.
Wow.
So now we're going to look at an article that Chuck brought to my attention, and that
All
is
right, we microscopic now, gang. Back down to
this is
quantum.
an atom, and this is the nucleus of an atom with a lot of neutrons and a lot of protons in it. And these other things out here are electrons represented, not to scale, obviously,
Yeah.
because the atom is mostly space and they would not be this close, except maybe in this new form of hydrogen. The idea is that we've known for a long time that neutrons are unstable particles when they're free in space. They have a half-life, which people quote of 10 minutes to 15 minutes. I've always seen the 15 minutes. This is a neutron, a free neutron. It's made of a down quark, an up quark, and a down to up quark. This one, doing this flip, creates a W particle, and then it breaks into an electron and a antineutrino. They put here, this is a proton, which is what the W signals in this diagram. And I don't know enough particle physics to tell you the relationship between the W particle and the proton. But this is a boson also, and this is a boson. But I was in quantum mechanics class with J.J. Sakurai in the 70s, and he came into the class one day really excited, and he said they've just discovered the J and W particles. So I remember he was very excited about it, but that wasn't my field, and I've forgotten what the subsequent lecture on the W particle was, so we'll look it up for next time. So anyway, represented here the way I learned it, free neutron decays into a proton antineutrino, which is that, and the electron, and some energy. So the proton plus some energy must be the W particle. What they've got here is there's been a problem like that. You've heard of the Hubble tension, about the different way you measure the Hubble constant, you get different values. Well, the published lifetime of the neutron is a similar thing. It started off with big error bars, and over time, from 1985, when they started measuring it, to the 220s, the most recent measurement here, they're getting down to this value, and it's shown here from 1995 to 2020, magnified, which is this portion of the diagram. So there's 2 ways of measuring it, just like there's 2 ways of measuring the Hubble constant. There's called the beam technique and the bottle technique, and they disagree. Just like the Hubble tension, which you can measure it from looking at the old universe, or you can measure it looking at the new universe, and you get different values. So here's another mystery like that. Now, let's see, I don't know if that's there. Here's the beam technique. This is the where you take and you look at what you have a beam of neutrons that you get from letting them decay, and you count. I'm drawing a blank.
What comes out?
You shoot the beam of neutrons in there, but you have something that lasts enough time that they can decay,
Yes,
and you count the protons coming out. So
Thank
that,
you.
that gives you the number that decayed.
right.
And we're doing this in
Why
the
would you
CERN.
get a neutron beam since they have no charge?
Right. They shoot.
So-
They have the beam going through there, but then they have a magnet there that deflects the protons for
Ah,
them to
okay.
measure.
But these
they
things
doing-
rely
are they-
on counting, and the counting is not considered to be accurate because the hypothesis now, and it is a hypothesis, although there's some evidence now, is that there is a version of the decay product that you can't count with either of these techniques. So that is, what's this? Oh, that's huh.
One of those.
Oh, we're
times
in
Chuck
the
loves.
thing that doesn't yeah, we're in the thing that doesn't respect my ordering of the
Beam
things.
versus bottle.
Yeah, hang on a second.
I always heard that a neutron was a proton and an electron squished together.
It's
That's
basically
also
why
the
they
an
have
idea.
no
Yeah. So
charge.
the idea is that this guy's proposing is that you get this is this is a neutron with its quarks in there. And
We're not seeing your screen.
oh, okay.
But you can tell us about it if you want.
No,
We believe you. Neutron stars are nothing but things crammed together to become neutrons, aren't they? The protons have been squished in with the electrons.
Yeah.
But
okay.
antineutrinos I've never heard of.
Anti-neutrino, don't worry about it. That's getting into particle physics deeper than we want to get, or that I can get. But
I know that. Okay.
this is a neutrino. This is a decay method for producing what's called dark hydrogen.
That's actually a gamma ray, right? Not a neutrino.
Yeah. Oh, yeah. Excuse me. A gamma ray. You're right. That's yeah. Yeah. Gamma ray. So
Coming
this
out as the squiggly line. That's the
Yeah.
gamma ray. Okay.
So this produces what the idea he's getting across, or he's claiming, is that you produce a hydrogen atom when the hydrogen has a neutron in it. And it decays to an electron and a proton. The proton and the electron form a hydrogen atom, but the electron stays very close to the nucleus. It's not in its usual energy level, so it does not emit light, and it becomes a hydrogen atom that cannot interact with the electromagnetic spectrum because it can't do it has to be able to decay. It has to form a dipole moment between the electron and the proton, and that has to be able to oscillate. Well, if the electron is too close to the atom, it's not in that lowest ground state energy level, and therefore it's very, very hard to detect with electromagnetic radiation. And he's proposing this as a source for dark matter, that dark matter is actually hydrogen that has undergone this difficult to detect decay mechanism. And the difference you see between the bottle technique and counting and the what was the other one? The stream.
The beam.
The what?
The beam.
The beam technique. The difference you see between those things is the number of decays that produced dark matter that can't be detected between these two things. So it's an interesting topic. It's a subtle topic. I've probably not done a good job of explaining it, but
Is Jerry, is that the red D, that the little bridge there? And I don't know if
That's the red D is a downed quark. This is a down quark. This is a down quark with different colors. You know, there's red, blue, and green.
But is this
quark.
dark? Is this little bridge? I don't know what that is. That theta or something?
Oh,
That,
this phi?
yeah. And is that what's causing the dark energy there?
Yes,
No,
that's
that's not dark energy we're talking about.
that's
Dark matter.
that's the exchange
Dark
of a
matter.
dark particle.
Okay.
That's the exchange of this electron that it cannot give off a electromagnetic wave.
So it's not being able to be detected easily.
Yes.
Okay.
By any chance, have you gentlemen heard about something going into the next dimension, a fifth dimension, making dark matter?
I've heard of the fifth dimension making music.
Right.
Yeah, that's true. Well,
This is
They
the
were-
age
they
of
were very good.
waves. So
we'll end it.
yes,
Well,
I
we
will
have-
do. One of my favorite topics is dimensionality, and I'll do that next time.
Okay.
Okay,
And
Well, you
please,
must
let's
have bonsai
if-
across the fifth dimension.
Yeah.
bring it up again. Continuing, there's plenty to talk about, gents.
Okay.
Ready also bring an appetite on Friday night at 5 o'clock.
Yeah.
We'll do it, I guess. Thanks, gentlemen. I learned a lot. Episode 223 of the Astro Hour. Next Monday morning, we'll be back here for number 224. And right now, Chuck is going to give us our official SBAU farewell.